Hello, folks, and are you all doing good? So, I believe that our Rust series is going well. We have already covered a bunch of topics, and we will cover a lot more. Now, in this video, I have decided to take things a little bit ahead, and we will be building one basic to do list backend in Rust. And in the next video, we will check how course policy works in Rust, and we will build a simple client, maybe in vanilla JS only. Now, I will try to cover things in as simple terms as possible, but there are some things that we will cover in detail later. So without wasting any time, let's get right into it. So in my VS Code, I have created one empty apps folder, and inside this folder, I will create another folder and I will name it to-do list Axum. Why Axum? Because this is an ancient kingdom in Ethiopia. This is the Rust web framework that we will be using in this video. Now I will go inside apps and to-do list Axum, and here I will create our backend project. So I will write cargo run, not run, cargo new, simple backend. And this will be one very basic Rust backend project that we already know. And I will go inside simple backend and I can do cargo run and we will get hello world in the console as expected. Now let me show you the main libraries and frameworks that we will be using in this video. And the first one is Axum. So Axum is a web application framework that focuses on ergonomics and modularity. And the next library is Tokio, a runtime for writing reliable network applications without compromising speed. Then we have Tower. Tower is a library of modular and reusable components for building robust networking clients and servers. And lastly, we have Serde. So Serde is a framework for serializing and deserializing Rust data structures efficiently and generically. So I hope you get a basic idea. Now let's see how to implement these things rather than going over the theory, which is also important, but we will be going through these things gradually, as I told in the intro. So now let's try to build one basic route using Axum. So first things first, I will be adding Axum as a dependency. And we can do it in two ways. The first way is we can do a cargo add Axum. And if I press enter, you can see that Axum is listed as a dependency below the dependencies. And the second way is what we want to do. And that is I have already listed out all the dependencies that we will require in this video. I will copy everything and paste everything over here. And now if I do a cargo run, it will start downloading everything and it will basically print hello world because that's all we have in the fn main. Now what we want to do is not to print hello world, we want to use Axum, and from Axum we want to import the router and also the routing, and from routing we want to import the get, post and delete. For now this is fine, I guess, and then we want to use our Tokio main. This is coming from Axum directly, so we don't have to use Tokio. And now we will create one async fn main function. And inside this function, we need one app. Then we need a listener. And lastly, we will have to do the Axum serve for both the listener and the app. And then we have to do one await and unwrap. So, what is the app and the listener is the bigger question. So, our app will be created using the router new, and then I will be creating one route. Let me first create the base route. So, I will only use a slash and then a get. And here I will be using closures and then async, and I will return, let's say, to-do list homepage. And for the listener, I will be using Tokyo net TCP listener, and I have to bind it to our localhost path or address. So I will use 127.0.0.1 and I will use the 3000 port, and I have to do one await and unwrap here. And that's all we need to create the basic route, and now I can do a cargo run and we can get it in our browser. And I can also do one debug print statement, so I can write println, and here what I need to do is I will print out my basically listener dot local address, local addr, and I believe this is good. Okay, so our app is ready, so I will go to our browser and here I will simply write, let me just open a new tab. So I will write localhost 3000 and we have to-do list homepage. So this thing works. Now, this is not an API, I mean, that we can use to build a to-do list, but at least the homepage is ready. Now, the next important thing that we want to do is not to run our cargo run every time. Rather than let's try to make it automatic. And for that purpose, what we can do is to cargo watch -x run, and it will do its job. And yeah, we don't have to bother it anymore. And one more thing is, instead of only printing our local address, which we are getting over here, let me write app running on this thing. And let me use hashtag, like colon hashtag question mark. And I will, things will work on its own. Okay. So that's good for now. Let me just minimize it. And what we want to do right now is to basically write the logic for our to-do list app. So, what are the things that we need? So, first things first, we need one model for our to-dos. So, I will create a mod called model. And for our errors, we need another mod, and I will name it error. So, basically, two more files. So, here I will create one error.rs and then one model.rs. That's all. Now, in our error.rs file, we will be specifying our errors. So we will be importing Axum, and from Axum response, and from response into response and response. And next thing we will do is we will create one enum for our errors. So we will use one trait called debug, and then we will use one enum for our error. For now, let's say there is only one error, internal server error. And I believe it's better to make it public also. So I will use pub enum. And then we will create one implementation. So IMPL into response for error. And what this will contain is basically one function. And let me name the function as into underscore response. And this will contain our self. And the return type will be a response. And what we want to write here is basically, let's say 500 internal server error. Lastly, we have to convert it to response. So into response. That's all. And lastly, one more thing I will write, and this is something I have learned from Jeremy Cohn. So you can also watch his YouTube channel, and he also makes awesome Rust tutorials. So I also want to basically use our result in this format. So I will use pub type result, not result. It should be result, and it will be of the generic type T. And I will use for result. And here generally it contains T and one error, and which is our error in this case. This will make working with errors a lot smoother. Now we will go to our model.rs file and implement our main to-do logic. And first of all, we will use create, and we want to use our error and result that we created. And then we want to use Serde, and from Serde we want to import serialize and deserialize. Then we also want to use our standard library, and from there we will import sync, and then we will import arc and mutex. We need these to basically store our to-dos and basically do stuff with it. I will now create some structs for our to-dos. And the first struct will be called to-do, and this will contain one ID, let's say of the type U64, and one title. This will be of the type string, of course. Now it can contain more things, for example, description or completed. But let's keep things simple for now, and we will only use these two. And the next struct will be called to do body. This is specifically for our posts, and this will only contain the title of the type string, of course. And lastly, we will contain a struct called model controller, which is basically our to-dos store. And it has a complex type, so arc, mutex, vector, option, and to do. So that's all for the structs. Now we also have to implement the functionality related to our to-do store. So IMPL model controller, and inside we will be having one async function new, which will basically create our store. So it will return not a self, but a result of self, and inside we will have OK, and we will have self, and here we can initialize basically some to-dos. So I will write to-do store, and inside we have arc new, then mutex new, and here basically we can initialize some to-dos. So I will write vector and let me write some to-dos. So every to-do will be wrapped in a sum because to-dos are of the option type, and we will have the ID and the title. That's it. So to-do, and let me give the ID as 0 for the first one, and the title will be one string. So we shouldn't write something like this because this is like a string slice, so we have to use string from. So let me give the first to do as write Rust code, what we are doing right now. And let me simply copy this thing, and we will do a second one, and that is write, let's say, TypeScript code. And let me also change the ID to 1. And now I will also be writing some methods for our handlers. So I will once again do IMPL model controller, and inside I will have three functions. So I will be having one public async function called create to do. Then I will be having another public async function called list to do's. And lastly, I will be having one public async function for our delete to do, because these are like the basic functionality that our app will be having. So now let's write all of these functions one by one. So what the create to do function will contain in the parameters. So first of all, it will contain the self. Self basically means our to do store, and then it will contain a to do body of the type to do body, and that is because when we are trying to create a to do, we are passing the to do body, and that is something what we want to add in our store. And what will be the result? The result will be simple, and that is result of to do. Now first of all, we want to see what do we have in our store. So I will create a mutable store variable, and here what I want is self to do store, and basically to get it I have to do a lock and then unwrap. And now let me create the ID, and the ID will be, let's say, whatever is our length, that is our ID, and that will always be unique also. So we have to do store.len, but it is not ensured that this is U64 or not, so I will write as U64. So we got our ID, and next we want to basically create our to do. So to create the to do, let me write to do equals to do, and we have the ID as ID, and we have our body basically. I think that is to do body. No, that is title. So the title will be basically whatever is our to do body. So to do body dot title. I think that's good for now. And lastly, we also have to do one OK to do. Now let's quickly write our next two methods. So in list to do's, we will have only the self as a parameter because I'm basically trying to return our to do store, basically whatever values we have here. And the return type will be result of a vector with each item being a to do. That's all. And we also need the store here, but in this case, I believe that we don't need the mute keyword because we are not trying to change the store. And then what we want to do is basically we will write let to do's, and we want to iterate over our store. So store dot iter, and then we will use filter map. And here we will be having access to a to do, and then we want to return the to do dot clone. And lastly, we want to collect whatever we have here so that we get a good collection of to-dos. And lastly, we want to return our to-dos. So, okay, to-dos. That's it for our list to do so method. And now we have our delete to do. And it requires the self and an ID of the type U64. The return type could be a result of to do. So we want to return the to do that we are deleting. And it also requires a store. So let me simply copy and paste from the above method. And the store should be mutable because we are trying to delete one to do from the store. And now let to do. What we want to do is basically store dot get mute. We will pass the ID as usize. And then we will use the method called and then we will get one to do and we want to basically do to do dot take. So I think this is good for now. And lastly, we have to return our to do. So we will return the to do. But in case we are unable to delete it, we want to pass an error. So we will do OKR and we will pass our basically error. And we only have the internal server error. Now, I believe that there are still some issues with our code, and that is we have defined some structs, but all of the structs need some traits that we also need to define. So on top of the struct to do, I will write derive, and the to do needs the traits clone, debug, and serialize. And similarly, the to do body needs the trait deserialize, and lastly, our model controller needs the trait clone. Because we are actually cloning our store many times. So all of these functions that we have written, we are trying to basically copy stuff from there. So we need this trait. And also one more thing I just noticed is that there should be a comma after our first to do. So I believe that's good for now. So the only thing that we now need is our handlers in our main.rs and then we can start our web app. Now we first of all need to import a few more things. So from Axum, I will import extract. And from extract, I will import state and path. And I also want to import JSON. That's it for now. And we have declared the model and error over here, but we also need to import stuff from there. So I will do pub use self and we will use the error. And from error, we basically want to take our error and the result that we have defined. And we also want to import stuff from our model. So what I will do is use create model. And from model, we want to import our model controller, our to do, and our to do body, I believe. Good for now. Now we can create our handlers as well as our routes. So basically the things that we will create are, we will create async function create to do, then one async function list to do's, and then one async function delete to do. Now the names are same, but these are not the same functions that we have defined in the model, but they will be using these functions, but these are different functions. These are like route handlers. Lastly, we also want to create a function for our routes. So I will write fn routes. And this function will be taking MC, which is our model controller as an input. And it will basically be giving the router as an output. Now inside, I will create our routes. So I will do routes new. And then we will have some routes, not inside the new. So dot route. So first of all, we will create a route for to-dos, which will contain our create to-do as well as our list to-dos. So I will do get of list to-dos dot post of our create to do, and then we will have another route which will be for to do's colon id. That means we can pass any id as a path, and this will be for our delete to do. So we will do delete of delete to do, and lastly what we need is the state. State basically means what is the value we are storing in our model controller, I mean in our to do store. So that is the last thing that we need. So with state mc. So let's write the list to do's handler for now. And let's see we get some to-dos or not. So the list to-dos will contain the MC model controller. All the handlers will be having this model controller. And we don't need anything else over here because it is basically like outputting the values of the store. And the output will be one result JSON. And inside the JSON, we will have a vector of to-do. Now inside, what we want to do is basically we will create one, let's say, collection, and we want to basically do mc.list to-dos, and everything is defined in the model controller, and do an await. And then we will simply do an OK of JSON to-dos. Now let me also write the create to-do and the delete to-do handlers. So the create to-do will also contain the MC model controller. On top of that, it will also contain one to-do body. And let me simply wrap it inside a JSON. So JSON to-do body. And this will be of the type of JSON to-do body. And the output will be something similar to our list to-dos. And this will be a result of JSON of to-do. We don't need a vector because we are only sending one to-do. So that's it. And now inside, we basically have to execute our create to do method that we have defined inside our model. So I will write let to do equals to mc dot create to do. And what we want to pass is our to do body. And then we will do an await. And lastly, we have to return our to do. So I will do OK, JSON to do. So I think that's good for our create to do handler. And lastly, we have the delete to do. And the delete to do will also contain the MC model controller, and it will contain one ID that should be wrapped with the path. And this ID will be of the type U64 that should be wrapped with the path also. So path U64. And the return type will be the result JSON to do because we are sending the to do that like we are deleting. So here again we will do a to do equals to MC delete to do, and we will pass the ID, and lastly we will do an await, and once again we will do OK JSON of to do. Now we also have to change our main function accordingly. So I will come down to our main function, and the main function will be returning one result, one empty result, and the same thing I will write below. So OK, and one empty tuple. And we have app, and what we need to do here is first of all initialize our store. So what I will do is I will write MC equals to, and how can we initialize the store is by writing something like this model controller new, because we have a new function associated with our model controller, and this that will basically create our store. So await, and I believe that's all. And let me also use the routes that we created above. So I will remove this get async to do list homepage route, and instead of this, what I want to do is I will nest everything under the base route, and I will pass my routes with a clone of our model controller. So mc dot clone, and I think that's good for now. The listener will be the same as it is, and we are doing an Axum serve of our listener and our app contains all of our routes and also a clone of our model controller. So I think we are good now, and we can now start our app. So I will simply do a cargo run, and let's see what we get. So it's building our app, and it may take a while, and we have some errors. Nothing unexpected when we are working with Rust, and let's see what are our issues. So it's saying the trait bound this IMPL future whatever, and the issue is in line number 43. I don't think there is an issue over here. Let's go to the function. Okay, so I believe the issue is we have to wrap all of our model controllers with a state. So what we will do is I will simply take these three, so control D and D, and I will write state, and I will wrap it inside angular brackets. Now I believe our issues will be gone. So let me do a cargo run once again, and our app will start building, and hopefully we have no issues this time. And our app is running. So let me simply go to my browser and let me refresh the page. This page is now gone. So I can go to to-dos, And we have our default to-dos in a very pretty JSON format. Now to test our APIs, I will open Postman and let's see if things are working correctly or not. So I have already made an Axum to-do app and it has three routes, so the get to-dos, post to-do and the delete to-do. So right now if I do a get to-dos, I will get write Rust code and write TS code, whatever we have given in our model. And so what we want to do right now is post a to-do. So in title, let me write JavaScript. And if I do a send, so we have ID2 and title write JavaScript. And now let me do something else, write Python. 1 second send. And we have ID3, write Python. So it seems like our to-dos are getting added. So I will do a get to-dos once again. And right now, as you can see, we have four to-dos, write Rust, TypeScript, JavaScript, and Python. Now let me try to delete a to-do. And let's say I want to delete the to-do with the ID of 2. Let me do a send. And it is saying that we are deleting JavaScript. And let me do a get to-dos once again. So right now we have Rust, TypeScript, and Python. So our routes are working perfectly fine. So this concludes the first part of our Rust web app. And in the next video, we will be building one very simple front end. And we will also see some annoying course issues and also how to solve them. So if you have learned something interesting in this video, make sure to like, share, and subscribe. It gives me a lot of motivation to create a lot more videos like this. And once again, I will see you next time.